All right, y'all. If I
Pretty
just
good
want to count
question.
down about 15 seconds, we'll confirm the stream's going in 10, 9, 8.
Welcome, everybody. Thanks very much for joining us today for this fun session on Ask Me Anything about Delta Lake. We've got a really cool panel here, so I wanted to go ahead and do some introductions now. Why don't we start at least to my left? Vinny, why don't you go ahead and introduce yourself?
Hi, everyone. Thank you for attending our session. I'm Vinny Jaiswal, Senior Developer Advocate at Databricks. Happy to join my other panelists as well.
Perfect. And TD, you're up next, at least according to my view of the world.
Okay. Hi, everyone. Thank you for joining the session, and thank you for having me in this session. I'm a software engineer at Databricks working on structured streaming and Delta Lake.
Perfect. Ryan, you're next.
Hi, everyone. I'm Ryan, and a software engineer at Databricks, and basically mostly working on Delta Lake and structured streaming.
Perfect. Barack, you're next.
Hi, everyone. My name is Brock. I'm an engineering manager at Databricks, and I've been working at Delta and structured streaming, and now focus on ingestion.
Perfect, perfect. Okay, well, thank you very much. My name is Daniel. By the way, I completely forgot to introduce myself while I was too busy introducing everybody else. I'm a developer advocate here at Databricks. Apparently know a little bit about Delta, so figured that's why I would MC today's session. So we've got a lot of great questions. We will actually stop exactly at 1 p.m. Pacific today, just because we've got a lot of good afternoon keynotes. So I'm going to go through the questions that we have. Please, folks who are interested in asking questions, chime in here. Let other people vote for your questions, so that way we can go ahead and chime in. All right, so first questions. TD, I'm going to direct this right to you, buddy, just because it is about merge, okay? So this one's a little bit more vague, so I figured I'd give you a heads up on this one. Sai Kiran, he or she's asked that they're experiencing significantly longer runtimes when performing merge operations with Delta. And then after the merge, the auto compaction write seems to take a very long time. So I guess the question is, are there any, number one, why potentially could this be happening? And two, like, are there any things we can do to possibly improve the performance? Okay.
So since this person is talking about auto compaction stuff, I'm going to assume that this is Delta on Databricks. So what could be happening is that merge is writing out too many small files because it internally does a shuffle and it writes out files, and it could be a partition table, etc. So there's a whole, for various different reasons, it could be writing out too many small files. One way to reduce the number of small files that it writes out is to enable optimized write. In some cases, the optimized write is enabled by default, but it might not be the case in your case, depending on which DB version you're using. So enabling optimized write might help. In other cases, it will be worth looking at controlling the number of shuffle partitions that needs to be set. That is set by 200 by default, and that could be causing number of small files. But I have to say, going forward, we are focusing a lot of our efforts on making merge perform better right out of the box, so that you don't have to do any of this sort of tuning. There's a whole lot of features coming in. There's faster version of merge in Databricks called low shuffle merge that is in preview right now. Talk to your Databricks contact for more details. There's other features coming in like auto optimize shuffle, etc. In Spark itself that eliminates the need for setting the number of shuffle partitions, etc. So yes, right now it takes a little bit of tweaking and understanding what's going on to do that tweaking. But going forward, this will not be a problem at all. Things will just magically work better.
I love it when you provide the answer, magic. All right, great. Thank you very much, TD, for that answer.
The hand movement is important.
Exactly. You have to emphasize it, right? So, all right. Next question on the list, which is actually a really good one, and this is open to anybody here, by the way, is that they want to really try to understand the line between Delta Lake and Lake House, right? There's these two concepts, and they sometimes they're merged together a little too tightly, right? And it's like, for example, the question that they're asking is, what do I need to add to convert my Delta Lake into a lake house? So it's quite open-ended, but there's a lot. I'm sure there's going to be a lot of good answers. So anybody would like to go ahead and tackle this question here?
Want to go first, Vinny?
Sure. Yeah. So Delta Lake is basically a structure, basically a format on top of your data lake, which allows you to enhance your lakehouse architecture. So think about lakehouse architecture as a unified platform, and Delta Lake is just one part of it. If you have data into Delta format, you will be able to leverage all the components like machine learning, SQL analytics, and run on top of your Delta. So you don't have to replicate the copies. It's basically, think of lakehouse as like a house built on top of your lake, clean Delta Lake. So that's how I would describe it.
I can add a couple more things on top of that. So, like Delta Lake is essentially, as Vinny said, kind of like the storage layer of your lake house. To, like have a complete lake house, you essentially need an execution engine on top of this. And kind of like having this open format being Delta Lake allows you to use different types of execution engines, such as Presto, such as Trino, such as, like proprietary, like systems like, Redshift, Spectrum, or Delta Engine to actually query the data that lies in your lakehouse. On top of this, you kind of like need a security layer to, help you govern, what is lying in your lakehouse. So again, here Databricks provides additional services. Like we just announced Delta sharing. That's like a very new way to actually share your data in a secure manner, as well as kind of like the Unity catalog. But that's essentially what it means. Like Delta Lake is kind of like the secure storage layer that gives you that table level abstraction that can work across different execution engines to have a lakehouse architecture essentially.
Yes. A tiny bit addition.
Oh, sure, go for it.
A tiny bit addition. So I think another way to think about this is that how crucial Delta Lake is to the lakehouse architecture is that you could build a lakehouse architecture with other 5 formats, but it will be a very poor lakehouse that cannot compete with the data warehouse architecture that you're used to, because without Delta Lake, you do not get the transactional and data quality guarantees that is present out of a data in a data warehouse. So to build an effective lakehouse, Delta Lake, storing data in the Delta Lake format is absolutely crucial.
Yeah. Last thing on top of that, kind of like, with, data lakes, everybody had to build their own database, essentially. And with, Delta Lake, you kind of abstract out all the complexities of, file management, transactions, schema enforcement and evolution, and, get all these data quality, guarantees that you used to get with databases and data warehouses on top of this massively scalable and, cheap storage system.
Yep.
Cool. Any other thoughts? Okay, we're good. All right, perfect. Thank you very much. All right, I did want to call out, has been a big question that folks have said, could you share more information about Delta Live tables? We're not going to answer in today's session, actually. But the reason why isn't because we're trying to ignore it. In fact, you'll join myself, but more importantly, Mate Zaharia and Michael Armbrust later today at 3:15 Pacific. That session, we will go ahead and dive into Delta Live tables. Okay, so let's go ahead and wait till then for those questions. Okay, so again, anything on Delta Lake OSS, Delta Lake, Delta sharing for that matter, we'd love to go ahead and answer those. But for now, anything that's Delta Live tables, again, we have a session later today specifically for that. Okay, so now that I've said my little piece, the next question on the list, and again, open to anybody here, is how frequently should you Z order index? Sorry, the Z order indexes should be refreshed on a table. And they're wondering, because of the fact that they have a composite Z ordered index, does that actually impact the refresh rate?
Yeah, I can try answer this. So basically for the order optimization, so usually we recommend you to do this like, the letter basically depends on how frequently you inject your data into your table. For example, if you use a streaming query, try to inject like pretty frequently, like every second or maybe every minute. You probably need to like try to schedule a Z order like per hour to make sure you don't have a lot of small files in your table. And if your Z order index is pretty complicated, for example, it may take a pretty long, you may consider to increase this interval. But basically, I think we need to look at the details of your data to see what we can do here. Yeah.
It also depends on kind of like your query patterns as well, like how frequently you're going to query that. And you're like, do you need the latest data to be available if you're going to query it? I mean, if you're streaming with low latency, probably you do want to see the latest data. So you might want to do, Z ordering more frequently. Regarding the completeness, I don't think, the second piece of the question was composite IDs. I don't think that changes how frequently you should be doing it, or at least I don't see any specific reason why you would do it more frequently or less frequently based on having more keys.
Right. It's really about how the data itself changes, and not so much the keys itself that are coming into play. And sorry, the data itself changes, and also the queries that you're running. So cool. All right. So I think we did a great job answering that question. Now our buddy Simon Whiteley, he's here with his question now. We've seen a ton of awesome features coming into an auto recently, and my apologies, I cannot pull off a British accent at all. Will we expect to see the same schema evolution, inference hints, coming to standard data readers, or is autolayer the ingestion focus going forward?
Yeah, I can take that question. So all of these inference and evolution capabilities will be available in kind of like the vanilla readers by specifying, proper options to those readers. But, autoloader will be our main focus of development, and kind of like how you bring new data into Delta Lake and from cloud object stores, essentially. And, like you can imagine that it'll be the easiest to set up, least amount of options to configure to get all these, features out of the box.
Rock on. Perfect. All right. Well, then let's go to the next question then. Well, we're clipping quite nicely. With the new capabilities such as Delta sharing and, well, the aforementioned Delta Live tables, can I leverage these lakehouse capabilities on federated data when my own data lake is rather small? So the context, of course, is that instead of our traditional conversations about having very large data lakes, right? In the petabytes range. Now we're talking about having, well, no, I only have a small data lake, right? It's not that massive, right? So can really things like lakehouse architecture or Delta sharing or Delta Live tables come into play?
Yeah, for like a Delta sharing, we actually have like a Python connector. You can load your like shared small tables as a pandas data frame. So you can use this to read any shared small tables. And basically this is we also see like people have a lot of small tables. They just like to play and share with other people. And we also have like an open server which share like several small tables. Everyone can try use like a Delta sharing connector to use. And for large tables, we also provide like a Spark connector. You can like use this connector to read large tables, which for example cannot fit into memory. So it's not easy to handle by like pandas. So in this case, we need some like a big data engine to handle.
Excellent. And one thing I'd love to add actually to this question is that the thing that people sort of need to remember when it comes to working with these type of technologies, right? For example, with Delta Lake, right? You can absolutely use Delta Lake even in a smaller environment, not necessarily just a big environment, because it is about protecting your data, right? It doesn't matter if you're talking about small amounts of data or big data, you actually need some transactional protections around your data. This is where Delta Lake itself actually is very helpful. Things like delta sharing. Just because you have small amounts of data doesn't mean you don't want an open standard to sharing your data. So that absolutely is super helpful, right? Even for technologies like Delta Live Tables, right? It's not, yes, it has the ability to scale for massive amounts of data, but the reality is there are things like governance, there are things like environment configurations and all of these other things that are very applicable to you, whether you're dealing with small amounts of data or very large amounts of data. So the reality is all of these technologies, when you think about lakehouse capabilities, are actually absolutely applicable to you, whether you're talking about small or large. What's great about Delta Lake and what's great about these environments is the ability to go ahead and as you scale up, you can do it extremely easily because the system, the environments are already designed for that. So that's just a quick call out. Anything else? Anybody else like that? Cool. I'm getting nodding approval. So let's go ahead and dive into some other questions. All right, perfect. All right. We're gonna go dive into some details again. So I'm pretty sure the engineers here are gonna love this one. Since you're defining vacuum and checkpoint properties when you're creating a Delta table yourself. Actually, let me go read that again. Sorry. Okay. Sorry. Because you're defining the various properties like checkpointing when you're creating a Delta table, do you need to actually trigger or specifically set up an explicit checkpointing or explicit vacuuming of the table when you do that? I hope that makes sense, what I just said.
Go ahead, TD.
Oh, me? Okay. So regarding checkpointing, everything is automated. You don't have to set up anything to explicitly checkpoint. It will just automatically checkpoint every 10 versions and it will take care of itself. Regarding vacuuming old versions, that is something you need to schedule explicitly and run explicitly to clear off files that are not needed by the last n days of versions anymore.
Just a quick add-on to that. If you join the Delta Live Table session, they'll talk about how these maintenance jobs are automated by Delta Live Tables as well.
Yeah, that's pretty cool, isn't it?
Yep.
And apart from one more thing I would like to add is we can also define a retention period just to make sure if you are not expecting any stale data, you have retention policies in place to ensure there is compliance around if you are dealing with GDPR laws. So by default, retention is 7 days, but if you would like to retain data for less time or more time, specify that in your code.
Yep.
Perfect. Thanks very much, Vinny. Okay, next on the line actually is a different question. I'm going to actually segue it off, but there's a great question actually about the Delta engine and Photon and SQL Analytics. Because we're talking about Delta Lake OSS and Delta sharing here today, we're gonna kibosh this question for now. But the only reason I'm doing that is because I actually forget exactly the time. I believe 3:30 Pacific today. There actually is an Ask Me Anything on Photon. So those are the right people to ask all those questions. So at 3:30 Pacific today, please go ahead and join that session for any of your Photon questions. Okay. So now let me shift back, and Ryan, I'm going to direct this at you because guess what? We're talking about Delta sharing. Woo! All right. How does Delta sharing manage the sharing of data or model versions?
So let's basically we define a protocol, which is, for example, a share means you have can have multiple schemas in a share, and then each share is like a database which can contain multiple tables. This is kind of the Delta sharing model, and for the server itself, we have an open source implementation. which you can like configure your server, define your all of these objects in a config file, and then after that you can share this table to like any people you would like to share. And in Databricks, we are going to like start a private preview, like which we will basically ship a beta server with the Unity catalog. So because we need like a Unity catalog to provide like a great like echoes with all these tables. So in Databricks, we will provide some beta like echo features with this data sharing provided by Unity catalog. And then so for everyone using like Databricks, and with Unity catalog, you can like for example assign a share to a specific user or something like this, and then only this user can access this share. Yeah, in future we may try to like improve our open source server to do all of this work, but in the current initial version, you need to configure a file to do this.
No, this is great. Thank you very much. This is awesome. And don't forget, go to delta.io/sharing. That gives you a reference to the blog, also to the GitHub repo. In the GitHub repo, we've got plenty of examples. Thanks to Ryan for being able to go ahead and doing all this stuff. So go ahead and give it a try, because we're really happy with this Delta sharing and pretty excited about it, as you can probably tell. So, okay, next question. And this is more of a generic question. That I'd love to go ahead and call out, which is basically, could you give some customer insights when comparing data warehousing to Lakehouse performance and or user experience?
Actually, Denny, Vinny, why don't you take this up? You have a lot more experience working with customers.
That's what they tell us, at least. So, Vinny, would you like me to go first, or would you like to go first?
Go first, and then I'll add, Denny.
No problem, no problem. Okay, so to provide a little context, I think the reason why TD teed this up for me is I'm actually a former data warehousing guy myself. So I'm formerly of SQL Server, and so with the SQL Server team itself. So yeah, so used to build a lot of data warehouses, and data warehouses obviously have a lot of really cool advantages, right? They had this one place, central location where you were, and from a user experience, it was great. I have just one DBA to choke, and it was awesome, right? But the problem, what it usually came down to, is that none of your data actually was always structured. Like it was never that way. It was never a point where I could always have purely structured data. Even if I had the structured data, I had to clean it. Even if I had to clean it, it was inconsistent. I had from multiple sources. So ultimately, it required us to have data lakes, okay? Because we bought into the fallacy of schema on read, which is like we can just go ahead and build a schema as soon as we dump the data into our data lake. But the reality is that that's why lakehouses became so important, because it was the idea of understanding that, okay, there are particular concepts of data warehouses, especially databases like ACID transactions, that became extremely important. And so from an end user perspective, what ends up happening is that they could finally trust the data that was sitting in their data lake. Before this, they were hoping their data was okay, as opposed to being truly able to trust. So now with Delta Lake, we're able to say, okay, I know what data exists. I'm comfortable with that, and we're good to go, right? But then what it happened was also from a manageability perspective. And so for anybody that debates me on the manageability side of the house, I usually turn around and say, well, yeah, it's true, managing SQL Server would be easier. I'm not going to debate that, actually, okay? But, and here's the big gigantic but, that's assuming all of your data was structured in a particular way. That's assuming that you could actually put everything into a single server. That was assuming that you didn't have connectivity issues with all these different sources, talking to REST APIs, assuming that you also didn't want to do machine learning on assuming you, and so forth and so forth. And not to mention, I actually forgot the most important one. My apologies to you, TD, streaming, right? So, right, the fact that in this new day and age, the reality is, yes, I could have the simplicity of managing a data warehouse, but it was very limiting, right? And there's all these other things that I need to do today that allow me to solve a whole new set of business paradigms that I couldn't do before. Well, the fact is that's why the lakehouse became so paramount. That's why it's so important. That's why Bill Inman, for crying out loud, Bill Inman, the father of data warehousing, is talking about lakehouses. Okay. And so, he was in the keynote today with Ali, right? This is that's even to me as a former data warehousing guy, that's pretty mind blowing. All we need to do is get Kimball in here, and then we're good to go, right? So that's more or less the context, right? That if you are thinking back in the day of if you could afford to just work in a data warehouse, maybe that's okay. But in this day and age, the reality is with all the different data domain problems that we have, the reality is the lake houses, that's why it's such an important shift for us. And so it's completely well worth it. And so I now shall get off my soapbox. Anything else, Vinny, would you like to add, or anybody else here would like to add?
Yeah, that was amazing explanation, Denny. Few things I have also seen from customers is, for example, right now when we think about big data, it's not just structured data. Now we want to do much more with like data which is not structured, like video files, audio files. If you are in a sensory industry, right, you want to understand those signals and how you can process that. So data warehousing doesn't go further into that aspect. How would you handle unstructured data? That's where you have data lake in the picture. Second thing is, if you are dealing with data warehousing, you might have to create bunch of copies. Now, if you create bunch of copies of your data, first of all, you are running into a lot of storage complexities, a lot of storage costs. Secondly, all these data warehousing, they are great at data management perspective, but everything is in proprietary format. So if you want to have integration with your other tools, you will need to, you will need to have some kind of connectors built in, or do a lot of manual processing. So you are wasting your time and resources into like getting that data into other formats. So in this time and age, you want to make sure that you are accelerating innovation and you are getting much more value of your data rather than getting into infrastructure problems. So that's where I have seen a lot of customers now, if they have like 10 years worth of legacy infrastructure, they want to migrate to the modern lakehouse. That's where lakehouse is kind of building that link. And other thing is, when you think about data teams, you are no longer talking about just SQL analysts. You are talking about machine learning users. You are talking about building deep learning models, AI. So all these things, if you remove data silos, because if you have so many proprietary systems, now your teams are siloed. Where are you going to get that vision? So with Lakehouse platform, everything is unified. So your teams are no longer siloed, and you have much more better understanding of data, and you can work together as a team to build that next AI innovation for your company that you want.
Awesome. Thanks very much, Vinny. Okay, perfect. We actually only have time for one more question. We've only about a minute or so left, so that way there's enough time for people to shift over to the afternoon keynotes. Posing to the engineers, whoever would like to tackle this question, does too many versions of a Delta table cause performance issues? It's the old data versioning, log versioning. So anybody would like to tackle that one?
Go for it, Burak.
Yeah, not when you're querying the latest version of the table. Like, I mean, having many versions doesn't matter with Delta. Delta is very quick in figuring out which version is the latest table of the version, and also being able to compute the state of that table at the latest, state of the version. So, latest version of the table. So having more versions will only show up as, storage costs for you. But on the query performance side, you shouldn't expect much query hits because of that, performance hits.
Perfect. Okay. We apologize in advance. There are still a whole bunch of other questions, but we had limited time. So I ask all of you to join us at delta.io. There is a Slack group. Since I can't really explain the URL for that, I'm not going to try to do that right now, but join us on the Delta user Slack, Delta users Google group. For that matter, even the Delta Lake YouTube channel, if you ever want to be bored with getting into the code itself, you're more than welcome to join us there. So, but go to delta.io for your latest information and links to all those different forums. All of us here are actually there pretty regularly, so hope to talk to you guys there. So that's it for us. Again, thank you very much for spending your time with us, and we hope you will continue having a lot of fun at the summit. All right, thanks very much.